This video covers setting up an environment for programming an assembled Atlas device. You can buy an Atlas kit from our Etsy store, and if you own an unassembled Atlas kit, you can watch the assembly guide before continuing with this video. Links to the store and assembly guide can be found in the description of this video. You can also find a link to the written guide on our website that goes along with this video. In the process of learning MicroPython for myself, I've used many different setups for programming microcontrollers. Through my journey, I found that the most streamlined and simple way of programming a microcontroller with MicroPython is through a program called Thonny. Thonny is a Python IDE that keeps the process of programming a microcontroller simple, which is great for beginners. Let's download and install Thonny now. If you're using Linux, then I recommend installing Thonny using the Python package manager pip. Otherwise, on Windows and Mac OS X, I recommend downloading the installer from the Thonny website. Go to thonny.org and click the download link for your operating system. Run the installer and follow the prompts to install Thonny. Now let's download the latest MicroPython firmware for the ESP8266 microcontroller. Follow the link in our guide or go to https://micropython.org, then go to Downloads ESP8266 and download the first link tagged as latest. Take note of where the firmware file is saved to. We will need it later. If you haven't already, plug your assembled Atlas device into your computer, then launch Thonny. Open a terminal. On Windows, this is called command prompt. In the terminal, enter pip install ESP tool. If this works, then you are good to go. If you get an error message saying that pip is not recognized, then you may need to install Python from python.org first. If you get an error about permissions, then you may need to try running the command again with elevated privileges. Before we can flash or erase firmware, we need to know the port of the ESP8266. On Windows, this can be done through the device manager. If you're on Mac or Linux, there's a link in the written guide on how to find your port on these platforms. In the device manager, we can scroll down to Ports, COM and LPT, and find the Silicon Labs device. The COM value in the parentheses is the port of the ESP8266. If you want to be extra sure, you can try unplugging and plugging in the Atlas device to see if it goes away and comes back accordingly. I found the port of my device to be COM6. Now let's erase any existing firmware on the device. In the terminal, enter the following command: esptool -- port, then enter your port, mine was COM6, then -- baud, and then type 115200. This is the speed of communication. Then type erase_flash, and then enter the command. This will run for a few seconds. When it is finished, check for the success message. If you see chip erase completed successfully, then you can continue on to flashing the firmware. To flash the firmware, we need to have the location of the firmware binary file ready. You can easily find this on Windows by going to the location of the MicroPython firmware file, shift right clicking on it, and then selecting copy as path. Then go back to your terminal and type the following command: esptool -- port, I'm putting COM6 again, -- baud 115200, write_flash, -- flash_size equals detect, -fm dio 0, and then paste the path to your firmware file that you copied. Then enter the command. This will take a bit longer to run. After the firmware is finished being written to the device, the Atlas kit is ready to be programmed. Now go back to Thonny and navigate to Run, select Interpreter. Make sure that MicroPython ESP8266 is selected. Then under Port, make sure that the port you found for your ESP8266 earlier is selected. Mine was COM6. Then press OK to close the dialog. At this point, you should see an available REPL in the Shell tab at the bottom of Thonny. It is denoted by the 3 greater than signs. If you don't see this, press the stop button at the top of Thonny. Let's enter a couple lines of code into the REPL to verify our MicroPython firmware. For the first line, enter import ESP. Then enter esp.checkfw. You should get a result like mine. Before we can make our first program for the Atlas kit, you should know that we have some starter code available that will aid you in programming your kit. You can find it on the Atlas MicroPython GitLab release page, which is linked in the written guide and in the description of this video. Click on one of the compressed source code links to download the source code. While you are here, be aware that you can look at the source code at any time by clicking on the details link. Then click on the files in the repository to view them. At the time of this video, there are currently just 2 MicroPython files in this repository: atlas.py, which has the Atlas class, and sounds.py, which contains a dictionary containing the frequencies of musical notes. Find the compressed source code file that you just downloaded and extract the contents. Go back to Thonny and make sure that you still have a REPL available. Press the stop button if you don't. Then navigate to File, Open, and click on This Computer. Then navigate to the extracted files from the Atlas MicroPython source code. Open the file called atlas.py. Now with atlas.py open in the editor, navigate to File, Save As, and select MicroPython device. For the file name, type atlas.py and click OK. After a few seconds, the file will be on the device. You can use the same process to put sounds.py on the device when needed. Press the reset button on the Node MCU on the back of the Atlas device. Then, when the REPL is available, type import atlas. If you don't get an error, then you're ready to use the Atlas class. You can now close the atlas.py editor tab. Let's write a quick Hello World program to demonstrate MicroPython on the Atlas device. Write or copy the following code in the Thonny editor. You can also find it in the written guide linked in the description of this video. This code will sequentially toggle the state of the 3 LEDs 6 times. When finished writing the program, navigate to File, Save As, and select MicroPython device. Name the file main.py and click OK. We name it main.py because MicroPython always runs boot.py first, immediately followed by main.py. Press the reset button on the back of the device to run the script. Your LEDs should sequentially light up like mine. You now know the basics of writing MicroPython programs for the Atlas kit. In the future, we will post more project ideas and tutorials using the kit, but in the meantime, you can head over to micronote.tech, navigate to Guides Atlas, and click on the Atlas MicroPython documentation link. This will open a book covering all of the features of the Atlas device and their usage through the Atlas class. This concludes this guide. If you want to check out more of our guides, head on over to micronote.tech. If you want to support the creation of more guides and kits, you can follow us on Twitter or subscribe to this YouTube channel. Or you can buy a kit from our Etsy store. Any support is greatly appreciated. Lastly, we want to start building Micronote into a learning community in a couple of ways. First, if you have any questions or discussion ideas, you can post them in the community Discord. Second, we want to start adding community content to our website. If you've worked on a project that you think others can learn from, fill out the community submission Google form to be considered for a community post. Links to our social media, Discord server, Etsy store, and community submission form can be found in the description of this video. Thank you for watching.